Hi, I'm Sydney Morgan, and me and Stuart Dervish created a AC to DC converter, and he will now explain what it does.
Okay, so first I'm going to discuss kind of a overview. The components we're using in our project are much too small to be able to handle the 110, 120 volts of power that are coming out of a wall socket. And so what you would normally use is a transformer, and I am not an expert on the matter, but as I understand it, it works something like this. So you have your 120 volts coming in here, and it's wound around a magnetic block, and it's wound very in a much tighter winding pattern than this other side here, and it works the same way that an inductor works, thus putting the magnetic field here, and they have the same resonance, but because this is a much greater space, then this voltage coming out is much lower than the voltage coming in. Okay, so that's the first thing we have to do, which in the lab we're using a function generator to basically bypass all of that, and we're just starting right here. But the reason we want to convert AC power to DC power basically works like this. AC power looks something like this. It's three colors and it's pretty. No, that's actually not true at all. I'm a horrible artist. Bear with me. So your AC power is a sine wave, and when it's above the midpoint here, then the electrons are flowing in this direction through the circuit, and when it drops down on the other side of the sine wave, it goes this way. Now our power coming out of the wall is at 60 hertz, which is, if I'm not mistaken, it's every 1 second it does this cycle 60 times. So within 1 second it's gone up and down, up and down, up and down, up and down 60 times. And what happens is, when power is going this way and then that way and this way and that way, it wreaks havoc on especially digital components. So what we had to do is create a way to get the power, the electrons, to only flow one way through the circuit. Introducing the rectifier. So what this basically is over here, this is the transformer, which again we didn't build, but the power comes up, and remember, it's just stepped down the voltage here. It's not it's still AC power coming through here, so 60 times a second it's swinging back and forth through here. But these neat little contraptions here are called diodes, and what happens is when it's on the upswing of its cycle here, upswing, the electrons are going this way, and when it's on its upswing, the electrons are going this way. When it's on its downswing, the electrons are coming this way. But no matter what happens, if you look at diodes kind of as a one-way gate, what happens is they go the direction of the arrow, but they can't pass the gate, this one-way line here. So electrons will come here and they'll split up here, then they'll hit this wall and they can't go, so they'll all come through this way. And then the next 1/60 of a second, the electrons are coming this way. They come up here and they can't go through this gate, so they'll come up this way, and thus you'll have electrons constantly coming in this way. And technically it's holes, but bear with me, just electricity coming this way, and it'll go through a resistor, and then this is where we come out. What this basically does is, instead of the cycle coming above and below this line here just makes it bounce like this. Well, so the problem that you're going to have then is basically this is off and this is on all the way, and so you don't want to have like your power just flash 60 times a second, because it makes everything look shuttery. That said, what you can do is introduce a new component to the system, which is a capacitor. So all of this looks essentially identically the same, except for with this squiggly line, which is a resistor, we also have a capacitor in line. And what a capacitor does is when there's a charge going into a line or into a capacitor, what happens is the power will like ramp up and then just hold, and then when the power drops, it will slowly bleed off the power that it's stored in a magnetic field between these two plates. If you think of it that way, there's a bunch of electrons piling up here, and then when the power comes off, all these electrons bleed through here. So what this capacitor does here is essentially it takes these peaks. When these peaks start to drop down to zero, then the power actually kind of bleeds like this. So then your line, while still not perfect, I mean an ideal DC voltage is just voltage, but ours instead is going to have a slight hump and a bleed off, and that's shown in we have an oscillator scope in the video, and you can see that there. But so from here you run it parallel with the resistor and the capacitor, and then this is your common coming, and this is your voltage going in from here. This is where your voltage, your positive voltage here, and your common or your negative out here. And then if you look at it off of paper, we have this. And I just wanted to show it a little closer than it was before. Maybe zoom in a little bit. You can see on these capacitors, they have the silver lines on here, so you can actually look and see here is the positive coming in, and it can go this way. The little silver lines on the capacitor are the same as the lines on the triangle here. This is the silver line on these diodes. So I'll move my arm out of the way of the light here. You can maybe see a little better. And then got your capacitor and resistor in parallel, and then if I turn it around to maybe give you a better view, this right here is your negative coming out, and this right here is your positive coming out. And obviously I'm not in the lab because there's not a bunch of people talking, so I can't plug it in and show you again that it works, but it does. Okay, what we have here is a function generator that is basically putting out a frequency of 60 hertz, an amplitude of 20, but some max and minimum voltage of around 10 volts. And this is what you would get if you had a transformer stepping down your voltage out of your wall socket to 10 volts. You would get this frequency and that amplitude. We're here running it through 4 diodes. You set up a rectifier circuit, and then across this resistor you get a positive current, because what happens is the power comes in here and it can only go this way when the amplitude is high, only goes through this way, but it can't go back in this way, but then it comes this way and it can't come back this way when the amplitude is low. I'm sorry, it comes in here, it can only go this way. So this side is always positive, this side's always negative. And then what happens is we can then take that and it makes a fairly uniform voltage in a direct current, though not 100% clean. As you can see, it's not a flat line. It has some wave to it. Actually, let's turn that off too, so you can see that.
Does that rise and fall and pulse?
But using that rectifier, we then come over here and we have 10 LEDs all lit up using an AC current.